Here, okay, today we're doing more factoring. And in fact, this is what we are factoring. It's in this format. ax squared plus bx plus c. That's like the formula of what we're factoring. All right, yesterday, your problems did not have, well, they had an invisible 1 in front of your x squared term. Today's problems are just a little bit more complicated. It adds a step to the procedure that we learned, and it makes the numbers a little bit bigger. That's why I put the calculators out. So you'll have a calculator to help you with the finding all the factors. But let me show you what we're looking at today. 6x squared plus 7x minus 5. Do you see how this is different than yesterday's? You don't see the difference? There's a number in front of x squared now that's not a nice invisible 1. It's much easier when there's no number in front of x squared. If there's a number in front of x squared, it just makes it a little bit more complicated. So what's the value of a in this problem? 6. A is always the number in front of x squared. What's the value of b in this problem? 7. 7's the number in front of x. What's the value of c? Negative 5. Now what you're doing here, yesterday all we had to do was look at the c number. And we tried to find products, pairs of products that would give you that c number. Really, you're always supposed to look at a times c. That's the product that you're trying to find. It's just yesterday, all the a numbers were always a 1. But today the a number is not a 1. What's the a number? 6. So we're not just looking for products that multiply together to give a negative 5. You've got to take the a value and the c value and multiply it together. So what is a times c in this problem? So we're really looking for pairs of factors for negative 30, not just for negative 5 anymore, because that number in front of x squared makes this a little bit different. Because think about when you multiply two binomials, the last term always comes from the first and the last getting multiplied. So you got to multiply the first and the last here. Okay, so let's think of all the pairs of factors that could give us a negative 30. I don't really assign the signs yet. I just think of the factors first. 1 and 30, 2 and 15, 3 and 10. Did we miss any? 5 and 6. Now, we need a negative 30. That means one of them's got to be negative and one of them's got to be positive. And they're supposed to add up to what in the middle? 7. A positive 7 in the middle. So what's my winning pair going to be? 3 and 10. Now, how did the signs have to work? Which one's positive? 10 has to be positive and 3 has to be negative. Now, doesn't that give you a negative 30 as a product? And what does it give you as a sum? Positive 7. So that's my winning pair right there. So we're going to rewrite this now as 6x squared minus 3x plus 10x minus 5. Now it's the exact same procedure that we did yesterday. Be careful with your GCF. You need to make sure you get out the greatest common factor. Whatever you pull out, your two parentheses should be exactly the same. And if they're not, then you did something wrong. Okay, for example, on the first two here, you don't just take out an x. What do you take out? 3x. We need to take out a 3x. You can't take out a 6 because 6 doesn't go into 3. So we're going to divide out a 3x. What's left? 2x minus 1. So we should end up with 2x minus 1 on the next set as after we take out the GCF. If we don't, then we did something wrong. What's the GCF here? I wouldn't take out a negative 5. Usually, whatever sign you have here, that you want to take. Like I have a plus sign here, so I want to take out a positive number. I want to take out a positive 5. What am I left with? 2x minus 1. Sure enough, I did get the same value in my parentheses. So now I'm going to take out that 2x minus 1. Now what am I left with? 3x plus 5. Those are my two factors that are going to give me my original product. This from here to here? Okay, so did you understand where I got the positive 10 and the negative 3? Did you understand the GCF? Okay, well, now it's still GCF basically. Okay, what you're doing is this is a giant product. Do you see how that's 3x times 2x minus 1? And this is a giant product of 5 times 2x minus 1. What are they both getting multiplied by? Well, both of these are both, what do they have in common? What does this have in common with this? 2x minus 1. So we're going to take out the 2x minus 1. The GCF now is a whole binomial, not just a number. So we're taking out the 2x minus 1 because it's in common to both of these. So if I take it out of here, what am I left with? The 3x. If I take it out of here, what am I left with? The plus 5. So it's GCF on a bigger scale. Okay, now, how can I tell if I'm right? Multiply it back. This is my answer. Your answer should definitely look like two little binomials getting multiplied. Let's check it. 2x times 3x, 6x squared. Then I would get a positive 10x, a negative 3x, and at the end I would get a minus 5. And the middle terms add up to 7x. Looks like that's the winner. If it equals what you started with, then that is absolutely the right answer. So basically, same process as yesterday, one extra little step. You always want to multiply A times C first, because that last term comes from this group times this group. The only difference yesterday is A was always a 1, so we didn't really need to do that step, but now we're going to have to do that step. Let's try another one. How about this one? 2x squared minus 11x plus 15. You always need to look at your A and your C. You got to multiply them together first. Signs and everything. So what's A times C in this problem? 30. So we're looking for the pairs, the factor pairs for 30, not just for 15 on this one. Give me all the factor pairs of 30 that you can think of. 1 and 30. 2 and 15. 3 and 10. 5 and 6. As your factors get closer together, you're getting closer to being done with your factor pairs. That's it. Because next we would go to 6. Well, we've already got 6 times 5. So we're done. Now, think about your signs. This is a positive 30, but look what we're trying to add up to in the middle. We're supposed to add up to what makes no sense. We're supposed to add up to negative 11. Which two pairs here could add up to a negative 11? 5 and 6. Now, the only way they're going to add up to something negative and still multiply to give positive 30 would be if they're both negative. Negative 5 times negative 6 is absolutely positive 30. And negative 5 plus negative 6 is negative 11. So we break this apart now into 2x squared minus 5x minus 6x plus 15. And then we start that GCF process. What's the GCF for the first pair? Just an x. And what am I left with? That means I'm supposed to get a 2x minus 5 out of the next pair. Now, do you see how this is a minus sign? That means I'm taking out something negative. 3. There is no x on both of these, so you can't take out an x. But 6 and 15 can both be divided by 3, so we're going to take out a negative 3. What would I be left with? Yeah, 2x, because negative 3 times positive 2x gives us back negative 6x. And 15 divided by negative 3 is a negative 5. Sure enough, look, I ended up with the exact same GCF. I ended up with a 2x minus 5 on both of those. So what am I left with once I take out that 2x minus 5? I'm left with x minus 3. If I take out this 2x minus 5, I'm left with this, the x. If I take out this 2x minus 5, I'm left with the minus 3. That's my winning pair. How can I be absolutely sure? Multiplying back. 2, and it doesn't take long, especially the more you do these, you can do them really quickly. I'm getting 2x squared minus 6x minus 5x, and I'm getting a positive 15 on the end. Sure enough, that adds up to negative 11x in the middle. Okay. How about this one? 2x squared minus 7x plus 6. Do you want to try one on your own? Don't forget, if you're not sure if you're right, all you got to do, check it. Who thinks they have the winning pair? Make sure you checked it before you tell me. All right, Chris, what did you get? Okay, I don't know if that's right because I didn't even do this, but I know I can check it. 2x times x, 2x squared, then I would get a negative 4x, a negative 3x, a positive 6 on the end. Does that look like the winner? Sure does. Let's go through this. First, you got to multiply a times c, which was 12. So we're trying to get a product of 12 that adds up to a negative 7. 1 and 12, 2 and 6, 3 and 4, and the winning pair had to be 3 and 4. And they both had to be negative. If you've got a positive number here and a negative number in the middle, you always have to have double negative signs. That's the only way it's going to work. Because it multiplies to give something positive and it adds up to something negative. Okay, so 3 and 4 was the winner, so we rewrote that as 2x squared minus 3x minus 4x plus 6. The GCF on the first two looks like x, and you're going to be left with 2x minus 3. I've got a negative sign here, so I'm taking out a negative GCF of what? Of 2, and you'd be left with 2x minus 3, sure enough. And then you take out that 2x minus 3, and you're left with x minus 2. All right, let's do one more, and then I'll feel confident that you've got this. Let's do one where you're going to have a very large number at the end. Actually, we're going to do two more because I forgot. We're going to do one with a negative value for a. 14x squared plus 31x minus 10. This is where your calculators might help you find all the factor pairs, because there's a lot of them. What product are we looking for? Not just 140. Negative 140. If your last term is negative, Or if your total is a negative total, then your signs have to be different. And by the way, I mean, there's a bunch of factor pairs here, but sometimes you can find what you're looking for and stop. Has anybody found the right pair yet? Not the final answer, just the right pair of factors for us. Danielle? Yeah, 4 and 35 was the winning pair. I started making my list, 1 and 140, 2 and 70, and all along I'm trying to see if it adds up to 31. 3 won't go in, then I did 4. I have my calculator there. 4 goes into 140 35 times, and I stopped right there and I asked, could that make a 31? Yeah, once I have the winning pair, I don't have to keep going. I mean, there's a whole bunch more. 5 and 28, 7 and 20, 10 and 14. But I found my pair because I'm always looking at what I'm trying to get in the middle. And it does have to be a positive 35 and a negative 4. That gives me a negative product, and it adds up to a positive 31. Okay, so now I'm going to rewrite it. 14x squared minus 4x plus 35x minus 10. And what's the GCF of the first two? Not just x. This is why you always got to make sure you get the GCF, or you're not going to have a common factor. It's 2x, and you're left with 7x minus 2. What's the GCF here? Positive 5, and you're left with 7x minus 2. Sure enough, you should always end up with these two amounts being the same. If you didn't, then you probably didn't get the greatest common factor out. I see confused faces out there. Where did I lose you? Now I'm going to take out the 7x minus 2, and what am I left with? 2x plus 5. Let's check it. That gives me 14x squared plus 35x minus 4x minus 10 on the end, and that adds up to the positive 31 I was looking for in the middle. That's got to be it. Okay, one more. When your lead term is negative x squared minus 2x plus 15. And this is the first time I've ever done one like this, so I'm going to learn with you. It's usually hard to factor when the first term is negative. It kind of puts a whole different spin on it. But I think this procedure that I just found out about this year, I think it's going to be helpful. Always multiply A times C. So what product am I looking for here? I'm looking for a negative 15. What are all the factor pairs of negative 15? 1 and 15, 3 and 5. That's pretty much it, right? Now I need a negative 2 in the middle. it's got to be 3 and 5. How do my signs work out? Positive 3, negative 5. Okay, so I'm going to rewrite this as negative x squared plus 3x minus 5x plus 15. And that still adds up to negative 2x, so I'm good there. Okay, what's the GCF of the first two? You could take out a negative x. Let's just try it with a positive x and see what happens. We'd be left with negative x plus 3. So I want to rig it to where I have a negative x plus 3 over here. So what would I take out now? Just a 5. Okay, so this is where it's a little tricky. I'm looking at what I want it to match over here. So I could take out a 5 and I'd be left with negative x plus 3. So then I could take out a negative x plus 3 and I'm left with x plus 5. Let's back it up a step because that did work. Some of you wanted to take a negative x out of the first two. Let's try it that way because it still should work both ways. And if you like it better that way, then maybe that might be an easier way. Let's take out a negative x, and what are you left with? X minus 3. That might make it better because now we're going to take out a negative 5, and you're left with x minus 3. So now we would take out x minus 3, and you're going to be left with negative x minus 5. So actually, there's more than one correct answer here. Both of these would work. Let's check them both. That would give me negative x squared minus 5x plus 3x minus 15. So that one works. This one would give me negative x squared minus 5x plus 3x plus 15. They both would work. Either one of these would be correct. So sometimes there's more than one way. Yes? Oh, I'm sorry. This is supposed to be positive 15. Negative 3 times negative 5 is positive 15. Good eye. Thank you. So they do both work. Okay, if you notice, they're exactly opposite factors. Like, instead of x minus 3, we had negative x plus 3. So these are exact opposites of each other, and these are exact opposites of each other. And they're going to give you the same product. So it is a little weirder when the lead term is negative. There's going to be more than one possibility. All right. Your homework is going to be on page 178. One to 43, first column. That's 15 problems. And there's none with a negative x squared. Do you want me to give you one for a bonus? All right, let's try 55 as a bonus. Okay, and that's it.